All good. Excellent. All right. Shout out at any point if I do anything you're not too happy about. And even if I'm doing something wrong, which has been noted. But what I just thought we'd do is just whip through the questions. So the ones that were in that little progress check. So yeah, just a reminder, they're the formula you get. So hopefully you had those to hand and you were working through the questions using them. It was intended to be a sort of thing that did get a little harder as it went further along. This question's pretty easy, isn't it? There's not really a lot to do there. We know that whenever we've got y squared equals 4ax as the standard equation of our parabola, then the 4a part is the length of the latest rectum, isn't it? So your answer straight away there is just 8 and you're done. Okay, so that's a nice easy question if you know that. Question 2, so we got the circle. This was a pretty well done question as well. We need to think about completing the square, so we collect the terms together a little bit. The 10x, we've got the y squared, and we've got a minus 6y, and we take the number across to the other side because we know all the numbers are going to end up there at some point because that's where we're going to get our radius from. And then we just got to think about completing the square. So we're going to get an x plus 5, half the 10, squared in brackets. And we're going to get a y minus 3, half the minus 6 in brackets. And then we just have to think about what joins the minus 9 on the other side. And when I square the x plus 5, I get a 25 at the end. I get a 5 squared, so that will need to go on the other side. And when I square the negative 3, still comes out to be positive. It's going to give me an extra 9 there. So I've got an extra 9 on that side as well. The 9 and the minus 9 take care of each other. So I've got r squared is 25, r is 5. Okay, but tended to be pretty straightforward questions to get into at the start. Right, now we've got a hyperbola. Our hyperbola has got vertices plus or minus 8 and 0, and the asymptotes are plus or minus 3/4. Because of the form of the asymptotes, we know it's centered on the origin, and we know it's centered on the origin anyway because of where the vertices are, symmetric about the origin. Give the standard form for the hyperbola. Now, the temptation here for a couple of people was to jump straight in to say, but I know that the standard form for the equations of the asymptotes is that y is plus or minus b over ax, and then you jump straight in and say, well, that must mean that b is 3 and a is 4, but that's not right. Okay, because the vertices tell us more information. The vertex of a hyperbola in this form is plus or minus a0. A is 8. Okay, yes, it is still true that b over a is 3/4, but because a is 8, b is 6. Okay, so it's important not to just get caught out by that bit there, the 3/4, and think straight away that's b and a told to me. No, it's actually telling you the proportion of b to a, simplified down as far as it can be. And we know that a is 8. So once you've got that point, you've got a, you've got b, we can say then b was 6, and we're straight into x squared over a squared minus y squared over b squared is 1. Okay, so that's that one. Question 4. Well, again, this is a completing the square one, isn't it? If we were okay on question 2, hopefully we're okay on this one as well. So we've got x squared plus 6x. We've got y squared minus 2y. And our negative 15 will go across to the other side to make a positive 15. So what do we need to do now? Complete the square, x plus 3 all squared. Plus a y minus 1 all squared. And that's a 15. And then what else do we need to bring in from the squares? So we've got 3 squared from that bracket would give us a 9, and 1 squared from that bracket, minus 1 squared, 1 squared, we've got our 25 again, haven't we? So straight away there, we've got the same radius we had before, 5. 25 is 5 squared. And then our centre is given by minus 3, comma 1. Okay, so we've got the plus 3 and we've got the minus 1. All right, now we've got a question where we're told the hyperbola and we're asked to say what its asymptotes are. Be careful here on this one because the y and the x are the opposite way around. Okay, we've got y squared over 36 minus x squared over 25. So we just need to be a little bit careful. All right, so in effect, if I think about it, I've got y squared over b squared minus x squared over a squared. If we keep the a's and the b's where we normally have them, equals 1. Now I know ordinarily, and I sometimes write these things in quotes, if it's given the other way around, I know that this is true. Y is plus or minus b over ax. But what's happened now to go to this form is the x and the y have swapped over, and the a and the b have swapped over positions as well. So really, what I'm saying now is this. Actually, I'll get rid of my quote in a minute because this is actually true. All right, so whenever x and y swap over and a and b swap over, that's what I need to think about doing. Swap them over in the equation. However, if you remember this, some of you remember we've talked about this before. If you rearrange that, what do you get? You get back to the thing that's in the quotes. Doesn't make any difference. Okay? If you're giving it in the other form and you're keeping the a with the x and you're keeping the b with the y, it is still y equals plus or minus b over ax. Rearranging this, the b comes up with the x, doesn't it? The a goes down the bottom. B over a. Y is b over ax plus or minus. So we're still in the same boat. B is 6. A is 5 on this one. So there we go. Y is minus 6/5 of x. Okay, so just be a little bit careful when they're the other way around. Actually, as far as the asymptotes are concerned, it makes no difference. We still get minus b over ax. Okay, now we've got a bit more of an involved question coming up. So we've got a parabola, and we're asked to write it in this form, which is now the standard form of a parabola because it's saying we're offsetting y a little bit, we're offsetting x a little bit, and use that to help us state the coordinates of the vertex and the focal length of the parabola. Okay, so that's what we're going to need to try and do. So I want all the bits to do with y on the left-hand side and everything else on the right-hand side because I've just got the y term there. Everything else I'm going to take over to the other side, so I'm going to have a 2x plus a 4 on the other side. Complete the square. Well, that's going to be a y minus 2 squared, half the minus 4. And I'm going to have 2x plus 4. And I'm going to need to put another 4 on, aren't I? Because the minus 2 squared will give me a plus 4 as well. So I've got to keep it balanced. That's giving me an extra 4. I need an extra 4 on the other side. So I've got y minus 2 squared. I've got my left-hand side sorted. But my right-hand side is 2x plus 8. I need to give it in the form that it said there. And obviously, factorizing it gives me 2 lots of x plus 4. Okay, that is now in the form that it asked me to do it. Y plus something squared, and then something times by x plus something. All right, so what am I able to say here? I'm able to say where the vertex is. The vertex, straight away given off here, get them the right way around. This is the bit where I sometimes go wrong and just start reading from left to right and go, oh, that's going to be 2 and minus 4 and write it that way around. But actually it's minus 4 and 2, isn't it, the vertex? Because you need the x1 first and the y1 second. The x1 we're going to get a minus 4. The y1 we get a plus 2. And we know that 4a is 2. Okay, reading off the standard form, 4a comes in front of the bracket. So that 4a bit there has got to be 2. So a is a half. and that's the focal length. The focal length is A. A is the distance from the vertex to the focus. So that was the last part you were asked for. The vertex and the focal length. Question 7. Right, the x-coordinates of the foci of the hyperbola. So generally this was started well, but some people just got a little bit lost at the end of it. All right, so if we start it off, we know that A is 8 and B is 6, because we've got that from the 64 and the 36. We know that straight off. But I know that the centre of this hyperbola has been offset a bit, and it's been moved to the point 1 minus 2. Now, ordinarily, my foci, if my centre is the origin, would look like that, plus or minus A0. But this has all been offset, so that it's moved to the point, the centre has moved to the point 1 minus 2. All right, so if I think about my hyperbola, what's actually happened is this point has moved out, okay, to 1 and minus 2, to down here. Everything has moved across 1 and down 2. So where my foci would be plus or minus 8 and 0, everything has to have moved across 1 and down 2. So it means I end up with, if I took the minus 8, it's moved across 1. I've got this the right way around, haven't I? Yep. Okay. And down 2. And if I took the plus 8, the plus 8 is going to cross 1, yeah, and down 2. We want the x-coordinates of the foci, so the x-coordinates are the minus 7 and the 9. Okay, it's offset a little bit because the centre has moved. So that's just what we need to be a little bit careful of on that one, minus 7 and 9.
I'm just looking at the answer.
Yep.
Seeing what I got.
Yep.
Is it correct answer
Minus 9 and 11.
Yeah.
Minus 9. Let me check that one then. Is the question wrong? Could be. Ooh, that's gonna have a real impact on the person who got 100%, isn't it? So it says minus 9 and 11, does it?
Yeah.
Let me have a look at that then. That's question 7, isn't it? All right. So. You put minus 9 and 11. But that's what Dr. Frost was saying the right answer was, so that has already been marked right for you. Let's have a look at that one. Okay, we'll come to that. I'll have a look at that. But there's nothing I've done wrong there, is there? That is right. Coordinates of the foci. Oh, no, I am wrong. Sorry, I've done the coordinates. Whoa. Stop. What have I done there? I've done the coordinates of the vertices, haven't I? Yeah? Good spot there, though. Okay, then, because that is the vertices. But I want the foci. Yeah? So the foci, if you remember, in a sort of standard form, let me do a standard form sketch. Well done, good job we caught that one. So the foci in a standard sketch goes like this. They're my vertices here. That would be A and minus A. So I don't think we need to take that 100% off. And the coordinates we have, the x-coordinates for the foci are C and minus C, aren't they? And remember, for a hyperbola, we have the relationship that b squared is, which way around do we have it? It's c squared minus a squared, isn't it? Can't get them the wrong way around because you don't with a negative. So in this case, I've got 36 is the c squared minus the 64. C squared is 100, C is 10. This now explains where. So we've got plus or minus 10, which move to minus 9 and plus 11. So if you got that, you don't have to have those marks taken away from you. You are right. That's what it was, yeah, because my foci would have been plus or minus 10 and 0. C is the position of focus. Good save there. Well done on checking the answers as we're going along, Caitlin, that it matches what Dr. Frost is saying, because that is right. -9 and 11. Okay, so the vertices, we didn't actually need that bit at all. We need to start thinking about the focus. All right, question 8. We've got another hyperbola, given the same way around. The equation of the asymptote which has a positive gradient. Okay, so we know generally, again, our form will be y equals plus or minus b over a. It is that way around, times by x, but it doesn't matter. We know if we've done it the other way around, as long as the a goes with the x still and the b goes with the y. So I know the gradient, the positive one for me here. Well, b is 2, isn't it? That's 2 squared, and that's 4 squared. So b over a, the positive gradient that I could get is 2 over 4 or a half. So I know the equation of my asymptote that's got a positive gradient will look like that with a plus c on it. How do I work out where that is? Well, I know a point that's on the asymptote. The center of the hyperbola is always on the asymptotes. All right, when we have our standard form, when we're going through the origin, our asymptotes always come down through the center, don't they? And we end up with our our hyperbola doing that kind of thing. All right, so the asymptotes always pass through the center. If we've offset the center to the point 4, 1, then 4, 1 will be on both asymptotes. So let's use that. The x-coordinate is 4, the y-coordinate is 1. Okay, so that's what we end up with. 1 is 2 plus c. c is -1. So the equation of the asymptote that I wanted was just y equals a half x minus 1. Okay. Question 9. All right, we've got an ellipse and we've got the ends of... Sorry. Oh, was that Michael? Do you want to ask something about that, Michael? Okay, what did you do, Michael? Yeah, so that's the other way. That's the other ways. Yeah, you do it this way, don't you? Which is the alternate way, isn't it? To work out the equation of a straight line. If you know the gradient and you know a point, you can stick that in. Yeah, it's going to be absolutely fine for you doing it that way as well, Michael. Yeah, just the same. Okay, so we've got an ellipse which has got the end of its major axis at the points -4, 2, and 4, 2. It's got a focal length, so it's just telling you what that means again. The distance from its center to a focus of √7. We need to give its equation. I think it's probably not a bad idea to start with a little bit of a sketch. So let's do that. Just have a little bit of a look at what it's doing. So its major axis, let's just think about this, they're both y-coordinate 2, and we've got -4, and we've got +4. Okay, so even the start of that little bit of a sketch is helping me a little bit, because it's helping me to see that actually this bit that I'm dotting in here, y equals 2, is the major axis. Okay, so the major axis is doing that. So my ellipse is going to do something like this. Okay, that's my ellipse. And the focal length, the distance from its center, well, I actually know where its center is now, don't I? Okay, it's quite clear that it's symmetric about the y-axis as well. So the center of this ellipse, I do know, has got to be the point 0,2. And it tells me that the focal length, the distance from its center to a focus, is √7. So, if this coordinate here is c, it's telling me that that distance there is √7. c is √7. Got too many c's, big C and little c here. But I also know, because this is the major axis and that distance from there to there is 4, I also know that A is 4. Well, I know C, I know A, I should be able to get B, so I've got the other bit that needs to go on the bottom here. So again, I just need to use that form, and for an ellipse, it's B squared is A squared minus C squared, isn't it? So in this case, B squared is 16 minus root 7 squared, which is 7. B squared is 9, B is 3. So now I'm in a position to be able to say what the equation of my ellipse is. Well, the offset for the x-coordinate is nothing because it's 0, 2, the centre, over A squared, 16, minus y minus the offset for the centre, which is 2 in the y direction, over 9 equals 1. That's a plus, isn't it? Before anyone wants to correct me and tell me I've just written a hyperbolas equation. So just drops out from there. But again, it's using that B squared relationship that you've got for the ellipse in this case in terms of A and C. And remember as well, we talked about this before, if you get that the wrong way around ever, it doesn't make sense. All right, so even if you find yourself using it the wrong way around and you thought, oh, is it C squared minus A squared? If you'd done that, you'd realize something has gone wrong, because C squared is 7 and A squared is going to give you 16. You end up with minus 9. Well, you can't square root minus 9. Okay, so you know something's gone wrong. B squared can't be minus 9. So that would tell you you've done something wrong. So you could just swap it around the other way. But there we go on that one. Question 10. So we've got a hyperbola symmetric about the x and the y axes. It's got one of its vertices at the point 6, 0, and it passes through the point 10, 4. Let's have a little bit of a sketch. What we're talking about. So it's symmetric about the x and the y axes. Well, that's quite nice. So basically it's telling us the center is the origin, which is what we like. One of its vertices is at the point 6, 0. Well, I know straight away where its other vertex is. If I wanted to draw it, I know it's going to be at minus 6 because it's symmetric, isn't it? So I know it's going to have to do that. And I know that 10, 4 is on there. And it's clearly on that particular half of the hyperbola. So 10, 4 is on there. What do I know to start off with? Well, I know because the vertex is at 6, 0, I know that A is 6. So I know that I've got x squared over 36 minus y squared over b squared, which we don't know at the minute, is 1. We've got the point 10, 4, so let's use it. Yeah, this key thing for us a lot of the time is using points that we know. 10, 4 is a point on that hyperbola, so put it in. 100 over 36 minus 16 over b squared is 1. I would multiply through by 36b squared to clear all the fractions. The common denominator of the fractions there, multiply through by it. Because this first part, the 36's will cancel and they get 100b squared. And on the second part, the b squareds cancel because I've got b squared here and a b squared on the bottom. So I'll get 16 lots of 36. I'm not going to work out what that is, by the way, at this stage, because I quite like the fact that these are square numbers, because I know at some point I've got b squared and I'm going to have to square root. So I'm just keeping that as it is for the minute. 36b squared. Okay, let's have all the b squareds on the left-hand side. So we take the 36b squared away from the 100b squared, and we've got 64b squared. And then on the other side, we've got 16 lots of 36. Becomes positive on the other side. Now just square root. Don't make it any more difficult than that, because everything I've got here is a square, isn't it? So just make it easy. Just say 8b. Square root of 64, square root of b squared, is 4 by 6. Yeah, so 8b is 24. B is 3. Now, technically, we should at this stage say plus or minus 4 times 6, But actually, it doesn't matter because we know we want b to be positive. All right, we know we want b to be positive. B is always positive in these things because we end up squaring anyway, so it doesn't really matter so much. But actually, if you think about it, once you've got to what b squared is, you can stop there if you want to, because once you've got to what b squared is, that's what goes on the bottom. So sometimes in some of these questions, you don't have to go all the way and work out what b is or what a is. If you just ask to give the equation of the hyperbola, you just want to know what the square is. So you could have come from this line here and just said, okay, well, let's divide everything through by 16, because 16 is a factor on both sides. I've got 4b squared is 36. The 16 will go on the other side, and b squared is 9. So we just end up at the same point, but we just don't have to work out what b is. So now I've got that. I've got x squared over 36 minus y squared over 9, and that was the hyperbola I was looking for, equal to 1. Question 11. Okay, this question's looks like it's just appeared out of nowhere because we were doing loads of stuff on circles earlier on, but this is just checking one thing, that you can figure out where things intercept axes. So that's all this question is there for. You don't have to do anything else with it, no completing the square, nothing like that. And the key thing is to remember that the x-axis, so the y-axis is x equals 0. So all you've got to do is put x equals 0 in. Y squared plus 10y plus x squared is going to be 0 minus 2x is going to be 0 equals 0. One of the simplest sorts of quadratics you can ever see. Factorize it by just taking the y out and then reading that off whenever we've got quadratics. Y equals 0 would work, or y equals minus 10. Okay, and we're done. Question 12. Right, got a combination here. We've got an ellipse and a hyperbola. And we tell the foci of the hyperbola at the ends of the major axis of the ellipse, and the vertices of the hyperbola are the foci of the ellipse. Find the equation of the hyperbola. All right, so we've got to do a bit of thinking around this to start with. I would be tempted to get the ellipse into standard form. So if we divide through by the 36, I'd say that's x squared over 9 plus y squared over 4 equals the 1. Yeah, because dividing by the 36, 4 over 36 is a ninth, and the 9 divided by the 36 is a quarter. So we got down to that. That helps me a bit because it's going to now help me to see, oh, what does this thing look like? What does my ellipse look like? Well, its centre of the origin, we know that. Its major axis, semi-major axis is 3, and its semi-minor axis is 2. So we know that is what our ellipse looks like. Terrible drawing. Okay, that's what our ellipse looks like. And the hyperbola, the foci are at the ends of the major axis of the ellipse. So I know the foci of my hyperbola are here. Right, okay, let's come to this. If you see 4 over 36 is a ninth. Yeah. If I have 4 over 36, divide the top by 4 and the bottom by 4. Yeah, okay. Okay then, Connor, yeah. All good. All right, so we've got that there. So what we know for our hyperbola, we know the C value. The C is the position of the focus. We know that C is 3 because that's where our focus is. Okay. What else do we know? The vertices of our hyperbola are the foci of the ellipse. Oh, hang on a minute. So the vertices of my hyperbola are there. So my hyperbola is going to come round and start doing this sort of thing. Okay, that's a kind of visualization of what's going on. Now, we've got the C value for our hyperbola, and I'm going to be careful to write that that's for the hyperbola here because we know that the vertices of H are the foci of the ellipse. So the foci of the ellipse we're going to need to determine. Okay, what those positions are. I know A, B, and C for the ellipse. I know A and B for the ellipse. Let's come to this. So for the ellipse, so I'm being careful here because I'm going to mix up my letters, what I'm using them for. But for my ellipse, A is 3 and B is 2. So, and I know that B squared for the ellipse is A squared minus C squared. Again, don't worry if you get it the wrong way around because you can always flip it. You'll know you've gone wrong somewhere when you get the square root of a negative. So 4 is 9 minus C squared. So C squared is 5 and C is root 5. But the focus of the ellipse is the vertex. So this here is root 5, is the vertex of my hyperbola. So for my hyperbola, I've got my A value because the vertices are at plus or minus A0. So for my hyperbola, I've got A is root 5. But also for my hyperbola, I know that C is 3. All right, we just got that on the original graph because we'd got it going through the endpoints of the major axis. So I can look at B, can't I? For a hyperbola, though, B squared is the other way around. C squared minus A squared. So I've got B squared is C squared, 9, minus A squared, 5. It's 4. B is 2. Now, do you see what's happening in here? We've got A, B, C, and I've got a 3 again. I've got a root 5 again, and I've got a 2 again. They've just moved around. Okay? So I've got my hyperbola. My hyperbola, I've got the A and the B values now, so I can just go through and say x squared. Well, what was A? It was root 5, so that's going to be over 5 minus y squared over B squared, and the B was 2, so that's 4, and that equals 1. All right, so that's question 12. And finally, on to question 13. So the Earth's orbit around the Sun is approximately elliptical. We're told the eccentricity, so 0.0167. The Sun is at one of the foci. Yeah. The minimum distance from the Earth to the Sun is 146 million kilometers. We've got to find basically the equation of the ellipse, which is the Earth's orbit around the Sun. And we're told that A is bigger than B, so we're drawing it that way around where the major axis is horizontal. Okay, so we give our answers in million kilometers to 2 decimal places. If you did this one and you started working it through, you would have got, they are pretty close. A and B are pretty close, so it's pretty close to circular, but it is elliptical. So let's just have a little bit of a sketch. What we have. So starting ourselves off, and we've got an ellipse, which looks as bad as most of the ellipse I draw like this. Let's put the Sun in here somewhere. So there's the Sun, and that's the path of the Earth around it. The minimum distance from the Earth to the Sun is 146 million kilometers. This is that distance here. Okay, so let me just call that point A for the moment. If we do that, so A to S is my 146. I'm going to measure everything in million kilometers just so that I don't have to keep writing massive numbers out. All right, that is the minimum distance that the Earth has to the Sun. Sun's at one of the foci. We're told the eccentricity. Okay, so this is where we're going to have to play in with the eccentricity a little bit here. 0.0167. Okay, now how are we going to start this one off? We need to be finding A and B. Okay, doesn't appear like we know very much information at the minute. All we have is this distance here. It's not a coordinate, and we have the eccentricity. Okay, so we've got to start thinking about how we can use this a little bit. Now, what we might want to start thinking about doing is using the fact, what do we know about the focus, the position of the focus? Well, the focus is always given by plus or minus AE0, isn't it? All right, if we know that way around, that's what the focus is given by. C is A times the eccentricity. All right, so often we give it as plus or minus C0. C is that. So what are we being told here? Well, our distance C, also we know that distance from there to there will be, well, this distance is A, isn't it? From the origin to the point A, that distance is A. So C, the distance to the focus, is A minus this 146. We know that. But we also know that that is A times E, don't we? Okay, because that's just what we're told. We also know it's A times E. Well, there's an equation for you that will let you work out A. All right, but the key thing is recognizing that this distance here can be determined by saying, well, it's the whole thing out to this end of the major axis, subtract the distance that we're told, 146. Okay, so we can use that to work out what's going on. So if I do that, I've got what? I'm going to need to use my calculator in a minute. Now, if someone's got one on standby, this will really help. So what have I got? I've got 0.0833 A's must be 146. And there's a 9 there for some reason. I don't know why I made that a 0.0. Okay, so I've just done the 1 minus the 0.0167. So that gives me the value for A. Someone got the calculator?
752.7.
Are we sure about that? It shouldn't be. Did you put the 9 in? Sorry. Just check on that. Okay, because that 9 is there, isn't it? For some reason, I put a 0 there to start with, but when I've done 1 minus that, I've got 0.9833. Could you do that one for us, Connor? Okay, 148.479. So it does say to 2 decimal places, doesn't it, in the question? 148.48. And now we've got A. Well, we can go around and we can get B. Because we know that for an ellipse, we know that B squared is A squared minus C squared. Remember, though, that this is C here, isn't it? We're saying that. You can work out the value of C once you know the value of A, and then you can just sub it in here to get the value for B. You know A, you can use that to work out C, then you're away working out B. And you can see why they're not going to be too far apart, because when I do this figure, A times by 0.0167, it's pretty small. It gets a lot smaller in comparison with a 148 than 148 is itself. It goes pretty small. So when you end up subtracting it away from A squared, B squared is pretty close to A squared. Okay, so you're just going to sub that in. You're going to do whatever you've got for your 148.48, but you're going to use the actual figure for that. Okay, so the actual figure for that, square it and subtract your 148.48. I know it's 479, isn't it? But what it is exactly, you've got it all on your calculator, so you're fine. Multiplied by the eccentricity. And then square it. Okay, so you do that bit squared, subtract that bit squared, square root tells you B. So hopefully you've kept that on your calculator. If you did that, Connor, what did it come out to be? Okay. Right. I think it was 148.46, wasn't it? I think it comes out to be, if I'm right. And Caitlin will tell me if I'm wrong, because she'll be looking at the answer in Dr. Frost. But I think it was 148.46. Right. How am I going from that? Right. Let me just jump back right to the beginning. I'm going to come back to this in a minute, but I think it was 148.46, but you can check through that calculation. I just don't have the calculator on screen in a minute. If I go all the way back here, right, formulas that we're given for the ellipse, this bit here is the useful bit. Yep. See that there, Connor? That's what I'm using. Yep. So the eccentricity is one of the formulas you're given. The eccentricity is C over A, or C is AE, which is what I've used in the question. C is AE. But it is one of the ones, yeah, that you can just use. Okay. From there. Okay. So it's, yeah, that's the one that you're actually given, and that's the one in there. All right. So they are pretty close, aren't they? But remember, these distances are in million kilometers. So, okay, they look pretty close, just as numbers in millions of kilometers, but those distances are massive. Okay. So that was that. Um, which one? This one is asking for the equation of the. It's just okay. Cool. That's all right. So, go on. So that one, I think, was actually attached to. I'm pretty sure it was attached to the lesson for the revision exercise. I put that one straight in there against that one. If you have a look, Connor, I'm pretty sure that's where it is. Once I get off the call. If it's not in that location, I will make sure it's flagged up to you straight away. You've got it in there, but I'm pretty sure that that's where I put it. No. Right. So let's. Is everyone okay with what I've gone through there? Does that seem all right? Yeah. You're probably kicking yourselves a little bit for some of the things. Yeah. But okay. I mean, that question 13 is a toughie. Yeah, you've got to do some thinking. It's not quite as tough as question 3 on the exercise we had before, where you'd got the satellite and the moon, and you've got to use the angle. But it's that kind of thing where you've got to be able to start it. You've got to be able to get out this relation here that A minus the 146 is A times the eccentricity. And unless you start with that, you've got nowhere to go. Okay, so that's the thing. The diagram needs to start doing a bit of work for you there. You're thinking about how all these things fit together, and you need to know that C is AE. Okay, so what are we going to do now? Well, the great thing is we're back on Monday, which is really good. I know this has been really hard on you guys trying to do this remotely, and and you've been putting an awful lot of effort in to keeping up, and you've been doing great work as well. Looking at where we are, I think we're in a pretty good place. Your understanding is there around this stuff. Yeah, it's not quite so good when we're not able to just be there and talk about stuff together. And that's all going to change relatively soon, so that's good. We do, Michael, have some more stuff that we need to do on this particular internal before we're ready to do it. So we probably have another week in school where we'll just be going through a little bit more material. So I don't know if you remember when I've been flagging up at the start of each one of these lessons, right at the bottom of the description of this particular topic, it said tangents and normals. So we've got that bit to do. All right, and it involves starting off with a technique called implicit differentiation. So we're going to have to do a little bit of differentiation to be able to do the tangents and normals bit, but that will take us about a week to do. Then we can get some practice in, doing some practice internals. So, I think realistically, after 2 weeks, we might be about ready to do the internal. Okay, so I think credit to you all, really. This time has not been easy at all, but you've used the time really productively. You've got your knowledge into good shape. Yeah, we can massage it a little bit and we can give it that extra boost over the next couple of weeks. But credit to you, the work that you've done. It's putting us in a really good place to be able to move on and get that internal done, not too far down the line. Anything else you think we should be looking at now? Any other questions?
About school going back Monday.
Yep.
What is the outlook like? Are we going to be? Do we have to be like separated desks? What's the deal with what?
So the thing is, all the classrooms will have antibac gel available. Okay, so you will have the alcohol gel. That will be there, and it will be protocol really for everyone coming in every lesson to use that. Everyone as they go to use it. We'll have protocols about cleaning the desks down at the end of lessons as well, just for the next person who's going to be in there. All right, so we're going to be making sure that we're doing all that kind of stuff. Now, for you guys, there are 14 of you in the class. You can spread yourselves out a bit if you want to do that. It's not going to be possible for all the groups that I teach. And what's coming out of the Ministry of Education is that they're saying, in terms of schools and so on, that's not a problem. There is no requirement at alert level 2 for us to be maintaining social distancing between students of 2 meters or even a meter. But what they have said is we need to, all of us, be really, really careful that we are not, sharing equipment that we shouldn't be sharing. Putting things, putting things close to our mouths, that sort of thing that we might be sharing, and also that we're not kind of invading each other's space a little bit too much and breathing on each other. All right, so I'm sure that wasn't the first thing in your mind that you were thinking of doing when we got back to school, but it's just, it's just these things about thinking about everyone's personal space and making sure that we're being as considerate as we can be around that. We will be having the windows open, the doors open, pretty much all the time, unless it gets really cold. We might close the windows up a bit, but we just need to keep that flow of air going through as well. So it is a bit of a step change because we don't have that same thing that we've been talking about with the social distancing in schools. The feeling, I think this, the stuff that the ministry have been looking at and the Department of Health as well have been looking at, showing that there isn't that big a concern around transmission between students. As adults, we're told we need to be a little bit more mindful of separation between ourselves. So the staff room will be interesting, but also that we need to make sure that we're a little bit apart from the students too. So, this whole thing about coming around and having a look at your work while you're working on it and writing in your books and, checking things over, we'll have to have a bit of a think about how we're going to do that. But that's where we are going back in on Monday, if that helps at all, Caitlin.
What about
So there will be no assemblies. Okay. So there'll be no assemblies for now. Again, because it's just a little difficult. I mean, some schools will be carrying on with those sorts of things. They've been told, they're not completely banned, but we won't be doing them in the sort of next few weeks. We're going to be trying to make sure that we're allowing that separation as much as possible.
What about school activities like football that's coming up?
Yeah, there's no more news on that at the moment. So the last thing I heard on that is what you'll have heard on that, Caitlin, that it's been cancelled. So we're just going to have to see what happens over the next few weeks, aren't we? If we're all good, behave ourselves, and we're doing the right things, who knows what might happen? Well, postponed. Sorry, I've been using the wrong word there, Lily. Postponed, rather. I know, it's things to look forward to, isn't it? That's the thing. They become more and more important times like this, don't they? Okay, so anything else I can help with for now? No? Okay, well, as I said, there's no more work for us to do while we're at home. But if there's any other stuff you want to check over and have a look at, feel free. If there's anything you want me to have a look at with you, it's absolutely fine. You know where I am, and we'll pick up on Monday. Okay then, guys. See you.